Welcome. So in this video, we're going to work through question 9. I'm going to be using the CAS calculator, but you could do all of this by hand. I just want to work through it a bit quicker. So let's see what it says. It says, a particle moves in a straight line, so its position x centimeters relative to the origin at time t seconds, where t is greater than or equal to 0, is given by this right here. First things first, find its initial position. We can do this. So we're doing A here. We're trying to find the initial position. So what we're going to do is simply go, well, when t is equal to 0, what is x going to be? So I'm going to go x is going to be equal to 0 squared minus 7, 0 plus 12. X is going to be equal to 12. That is going to be the initial position. And remember, we should write down what this actually means. What this means is it's 12 centimeters to the right of O. That's what it is. Let's highlight that and let's move on to our next one. That is A. Done. Let's now go on to B. What is its position at t is equal to 5? What? This is easy. We can do this. All we have to do here is go t equals 5. Well, x is going to be equal to 5 squared minus 7 on 5 plus 12. Now, I did say I was going to use my CAS, so I might as well start using it now. Let's come over here. Let's come here. Let's begin by defining what x is. So I'm going to go x of t, control this, is going to be t squared minus 7t plus 12 is that. And now I'm finding when x is 5. Sorry, when t is equal to 5, so x of 5 is 2. So after all of that, I'm going to get x is 2. And again, let's write down what this means. What this means is that I'm 2 centimeters to the right of O. Let's give that a highlight and keep walking through this question. Whoa, what's happening there? Give it a second. Wait for it. Bang. Okie dokes. Let's go on to C now. I might even just work down the page like this. C. Find its initial velocity. Okay, so to find its initial velocity, I know that my velocity is going to be equal to dx dt. So I'll come here and I'm going to go, let's define my velocity, v of t, as control this, shift minus dx, and then, oh, sorry, dt, you're differentiating with respect to t of x of t. Done. What is it? What is v of t? It's that. So we could write that out. V of t is 2t minus 7. Perfect. All right, let's keep on working through these problems here. We found its initial velocity. The next thing that we need to do now is, oh no, we haven't found its initial velocity. We've just found that. We actually need to finish the question off there. Don't just do that. Find its initial velocity. Well, what I'm just going to do now is to go, well, what's v of 0? So when t is equal to 0. And that's going to be 2 of 0 minus 7 is going to be equal to negative 7. Just like that. Again, it's probably a good idea to write down what this means. What does it mean to have a velocity of negative 7? It means that I have 7 meters. I'm moving 7 meters a second, moving to the left of O. That's what it means. So I'm moving to the left because it's got that negative 7. So when we're writing that down, that's what we want to be thinking of as we're doing it. Let's give that a highlight. Let me just write moving to the left. I'm moving to 7 centimeters, moving to the left. Okay, we're going on to the next one, which is D. When does its velocity equal 0 and what's the position of this time? Okay, all right. This isn't fun. So what we're going to do is we're going to go v of t when it's equal to 0 and solve that for t. What is this initial, what is the velocity, when does this velocity equal to t, and what's the position that this occurs? So I'm going to go, let's solve v of t when it's equal to 0 for my t values. It's going to be that. And then we also want to find out the position that this occurs at. It's going to occur at that point right there. So it occurs at 3.5 seconds, and the position that it is going to be at is going to be x of 3.5 is negative 0.25. So 0.25 to the left of the origin is its stationary point. So I could write that down. At rest at 0.25 to the left of O. That's where it's at rest. All right, let's keep on moving here. The next thing that we have to do is, what is its average velocity in the first 5 seconds? Okay, so if we're going to be finding average velocity, and I might come over here to do this. Let me just zoom out a bit. We're finding the average velocity in the first 5 seconds. This is where we have to be careful. Remember, it's the change in position over change in time. So what I can do here is just say, well, it's for the first 5 seconds, am I right? Yes. So it's going to be, what is x of 5 minus x of 0 over 5 minus 0? And I could just chuck all of that into the cas. So I could come here, let's go control this, let's go x of 5 minus x of 0. Then this will just be 5 minus 0. My answer is going to be negative 2 centimeters a second. Negative 2 centimeters a second. Perfect. Then next it says, what is the average speed in the first 5 seconds? Now this is asking for something different. That's why they've used a different word. Let's come here, A, B, C, D, wait, what? F, right? Yes, I do know my alphabet. Let's go speed. So we're now going to figure out average speed, which is going to be change in distance, not just change in position, change in distance. Oh, sorry, let's just say distance. Let's just say distance over time to make it really straightforward. It's just my different distance over time. That's my, that's what it's going to be. So what I need to find now is my total distance. That's what I need to find. Now you might be thinking, that doesn't sound too hard. So if I'm finding the average speed, I just need to find the total distance. You know, how hard could that be? But what you have to be careful with here is that you have a good picture of what's going on in your head. So let's draw ourselves what we're dealing with here. So I've got this, there's 0. Now what was my initial position? My initial position over here was 12 centimeters to the right of the origin. So let's come down here now and put in that. So I'm here, 12. This right here is where I'm starting. Okay, next. The next thing I want to put down is my stationary point. So my stationary point is at rest at 0.25. So if I come here now, when I come here, 0.25 to the left, it would be like here, 0.25 minus. That's where I'm stopping. I'm at rest. It's resting. And this is when t is equal to 3.5. Now I also know that when t is equal to 5, I'm 2 centimeters to the right of the origin. So now this is way out of whack, but it's not to scale at all, but it will do. This will be t when t is equal to 5. So that means And my velocity, you know, it's moving to the left, right? Now, wait a second. Wait a second. Yeah, that's good. Yeah, my initial velocity is moving to the left, which makes sense. I'm starting here, I'm moving to the left, I'm stopping there, then I'm coming around. That makes sense. So I'm starting here, I'm going left, I stop, I turn around, and I go there. That's what it looks like, except it should look prettier. And that's what we found. My initial velocity is -7, which means it's moving initially to the left. So it's going to the left, it stops, it turns around, it goes there. So if I want to find my total distance now, just be careful. We don't want to mess this up. From 12 to 0, that's 12. From 0 to -2.5, that's 0.25. From 0.25 to 2, well, think. 0.25, I have to go back to 0. So let's just plus another 0.25 there. And then once I'm there, I need to go to 2. So then I have to plus 2 there. And then you just come to your CAS and just add all those up. So it was 12 plus 0.25 plus 0.25 plus 2 is going to be 14.5. That's the total distance traveled. 14.5. So that means my distance is 14.5. And we know it's a total of 5 seconds. So now we would come here and I would go control this. What is 14.5 over 5? It's going to be 2.9. 2.9, and it was centimeters a second. And that's going to be your answer. Take note of the fact that the speed is always, you don't put a sign there, it's just always positive. But your velocity does have that direction, that sign there. Okay, that's it. That is how you do that question. That is question 9. Hopefully that made sense of how to approach it. I'll see you in the next one.